In our last video, we are going to complete our infrastructure as code project by configuring EIGRP and BGP to give the routers and the PCs complete connectivity with each other. And at the very end, I want to show just a little example with using NETCONF as the transport protocol. So far, we've been using the CLI-based method, but you can also use other methods such as NETCONF, and I'll show a quick example of that. But for our topology here, we have routers 1, 2, and 3. We're going to, in this video, configure EIGRP on them using Ansible roles. So it's a continuation of the last video, and we'll see some good examples of how to make, different role names. And I'll base it on features, and then we'll make another one for BGP because router 2 has a connection to the ISP here. So where it stands now, PC 1 can hit the default gateway, 2 can hit the default gateway here, but that's as far as they can go. So let's continue by setting up EIGRP. So let's make a new EIGRP role real quick. So we have a new role called EIGRP. We made the tasks folder, and then we made the main.yaml, which is empty right now. So we're going to populate main.yaml directly in this case. I won't make anything and do an import. I'll just do it directly here because it's going to be simple. And we're going to turn EIGRP on essentially all the interfaces on these 3 routers. So let's just build a playbook to turn the interfaces on, and then we will map it to these devices. So in this simple task, it's a single task, we are running 2 parents, router EIGRP, and then just EIGRP is the name of it. And we will configure IPv4 autonomous system 1 and then put all interfaces in there. So the module we're using is the iOS config module because there's no specific EIGRP module. So when there is nothing specific, we kind of fall back to this config module. But again, kind of the trade-off here is you have to know the commands. Like these are actual commands, whereas before we saw more intent-based. Here we need to kind of know the commands. But no big deal because this is pretty simple. So that's what the task looks like under the EIGRP main.yaml. Now we just need to assign this role to some group that we have. Now we already have this file right here, which we already have this applied to the routers. So if we want the routers, remember this is a reference to our inventory groups. So that's what this is targeting. We can simply add the EIGRP role here. So we come down here and simply add the role. And so now all these routers will apply any configuration in the main file of the EIGRP roles. So that is all that we really need to do to get EIGRP going, besides just simply running the playbook for our entire automation. So let's run this and check the new changes. While that's going, I'm going to quickly see if I can pull up the routers and do a show IP EIGRP neighbors. Hopefully I'll catch this real quick before it makes the changes. Oh, it looks like I might have missed it. They were all in different states. Okay, it's still going through the interfaces. All right, there's our EIGRP. It says it changed on routers 1, 2, and 3. Okay, so it made 3 changes. This is still, it's still actually trying to do a resolution, but we can actually see the neighbors have came up here. So on router 1, show IP EIGRP neighbors, we should have 1 neighbor to router 2. It's been up for 29 seconds. And then on router 2, whenever it stops getting hung up, let's look at router 3. This should be enough to verify it. There's our EIGRP adjacency to router 2. It's been up for 50 seconds. So I checked it from 1 and 3, and they're both up to 2, so we know 2 is up. It's just hung right now. And it made 3 changes. So that's really all. That was a fairly simple role we added. We can do a kind of a final check here by seeing from PC if we can ping PC2, so 20.0.0.10, I think it was. And we do get a response. So we do have full reachability now between PC1 and PC2, all done through code. Now, on router 2, we don't really have default routes. So if I were to go to router 1 and just kind of look at our routing table, it's pretty simple. We don't have a way out though, so there's no default route, there's no anything to get us out. So what we're going to do now is go back to our control node, and we're going to make another role called BGP, and we're going to only apply it to router 2. So let's do that real quick. So here's our new role called BGP. Again, we follow the structure. There's our main.yaml. Let's populate main.yaml with a couple plays to configure BGP, and then we're going to redistribute BGP into EIGRP because we want to propagate that down to all the other routers. So in this example, we can use, if we go back, there is a BGP module we can use. So looks like there's a few. And I think the one that we can go with is BGP Global. And then we'll use it by referencing this. So let's go into the main.yaml and populate it with a couple tasks. So what we have here are 2 tasks that are applied to the BGP roles. One of them we're using the module BGP Global. It takes a config, and then it takes autonomous system number, so we are in 65,000, and then we give it networks and we give it neighbors. Now if we can clarify what that is, if we go find networks, which networks is directly under the config, so it's going to be at this level here. There's neighbors, so we came to this one first. So item.neighbors, that's a list of neighbors. So if we remember that that's a list, we'll look at the inventory here in a second. So neighbors and then networks. Here's networks, and it is also a list. And this is a pretty big file. I had to scroll for a long way to find it. And we're going to loop through something called BGP, and then populate these values, and we'll look at that here in a sec. Then we redistribute BGP into EIGRP. Here we're doing this back to our general config module, and we're giving it the exact lines. So we type in those 3, and then we redistribute BGP and give it the metric here. So let's save this, and then let's look at Ansible inventory list, but let's look at router 2. And this tells, remember, this is a way to look at what our inventory knows, how it inherits all the variables that we give it. So we have the interfaces, and what we need to do, because we actually have not given the BGP yet, notice that it's missing. So we need to go to our router 2 host vars, we need to put in here a BGP section. So all we have in here is the interfaces. So let's give it, let me fill this out real quick. All right, so here's our BGP. Now remember, it took networks and neighbors, it took a list. So we're going to make a list, but this has 2 items in the list, both address and netmask. So this is what it's going to go. It can go under the BGP process and say, these are the networks we want to distribute out. And then there's our neighbors. Now for 2, this address here is the ISP. So that's going to be the ISP address. The ISP is in 65,009, and then we want to make sure we activate it. So if I take a quick screenshot of this, just to be clear with how it works, let's save this and then go back to our tasks. Now we can look at these and how it works. So what we have on the right is our host variable representing the router. Notice we have a loop here. We're looping through BGP, and there we have a config AS number is 65,000. That we're hard coding that right here in the task. But then we give it item.networks, which is this whole thing right here. And then we item.neighbors, we're giving it's a list with one item in it. Now the reason I put it in a loop is because we could have more networks. So I just sort of set it up for a future expansion. And then I think we understand the redistribute here, what it's doing. It's going into EIGRP and then redistributing that out. So now how do we apply this to just router 2? Because we don't really have anything that's specifically just made for router 2. So one thing we could do, let's go to our inventory file. We can just make a new group here. Let's call it BGP. And then in it, we'll just put router 2. And it does need to be under hosts. Yeah, so we're just going to add a new group and just put router 2 in it. Once we do that, we can make a new file called bgp.yaml. This is going to be for kind of our roles. And we'll target this to BGP. That's again what we just did in our inventory file. We're going to assign it the role of BGP. So just to be clear, that's our inventory group, and then the roles is where we put those tasks. So that's how that's how it ties it all together. All right. And then finally, the last thing is on our main site.yaml that we kick off, we want to include what we just made for the BGP. So we're going to add this. Now that we have this, I think we are ready to kick this off and configure BGP on router 2. So let's look real quick at router 2. Show run section BGP. Show BGP. So there is nothing here on router 2. Show IP route. And we should expect to pick up 1 or 2 new routes here. So let's run our playbook. And this will be for our full automation here. So it's starting our BGP now. Notice our EIGRP above was idempotent. It didn't make the changes again. And here it said it did make some changes on router 2. So it's done. So let's see if we can look at router 2 on the console here. And do we see if BGP is up yet? Sometimes it's slow coming up. But if I go to show BGP summary, so it's not up yet. Let's see if it show run section BGP. So it did do all these changes because while ago this was blank. Let's see if it's reachable. And let's make sure our interface is up. Let's verify the config on gig 3. So there's no IP address on gig 3. Okay, interesting. So we missed something somewhere. Let's go to our host vars file. And it looks like I need to actually put router 3 here, so I must have forgotten about that. So we're going to put a new interface. Okay, now that we have this, let's run our automation again to configure that interface. And to make it a little faster, what I can do is limit any changes to router 2 to maybe speed it up a little bit. And there's our change here for router 2 on the interfaces. So I'm just going to go ahead and pop this open. And there's our neighbor right there. So our mistake there was we forgot to configure interface gig 3. So now that gig 3 is up, we know BGP is up now. And we are learning one prefix. So let's do show IP route. So now we're learning a default route from the provider. So now we're pulling down default route, and our redistribution should have kicked in, and router 1 should also know about this route. And there is the default route on router 1. Now let's go to the PC. Let's see if we can ping. I just have an emulated, internet. 8888 is a loop back on the ISP. So we have good reachability there. What about from PC2? So we have good reachability there. So now we have the ISP can get back to us. We can get to the ISP. It's all going through router 2, BGP, EIGRP. So we have this infrastructure as code complete. Now there's much more we can do with Ansible. We're just kind of scratching the surface here. But this was a good kind of getting started. So let me clear the screens here and we will look at a quick NetConf example. So to finish up, what I wanted to do was configure a switch to have an ACL and then apply that ACL on a port just so we can kind of see it work. So what I want to do is configure an access list to block the 8888 that we were pinging. So we should also be able to ping 9999 just as an example. That's just another loopback on the router. So what I want to do is filter 8888, just something we can do. So one way we can do that is use NetConf. And to make this simple, I'm just going to make a traditional playbook, call it netconf.yaml. And then here I'm going to populate this real quick. Okay, so what we have in this quick playbook here is we have 2 plays. One of them enables NetConf. So we have to enable NetConf with the CLI, with the iOS config. So I'm giving it 3 commands here. I generally find that I have to have these 3. Now I'm also making it possible to do RESTconf with the HTTP secure server. I'm just hitting them both here with one task. So once that is enabled, what we can do, notice on play 2, I set a new variable here, and that's the Ansible connection. This is going to override the one that we have in our host vars all.yaml file. We're overriding that here, so this is at a more specific place. So what I'm telling it is I want to connect via NetConf now, and I'm running this on just the switches. So it's not going to be try to be applied to the routers. And then here's our task. Now all this is XML, not necessarily going to go through all that because sometimes it's kind of hard to find exactly what you need. The current tool is Yang Suite to help with this. That's what I use to get this, but you can kind of see what it's doing. that's making an access list. There's sequence 10, deny IP, and then there's my 10.0.0.10. When it tries to go to 8888, I want you to deny that. And there's our action deny. And then we permit everything else. So that's the creation of the access list. And then if we go to the second task, it's the application. So there's our access, there's our interface, gig 101, which is where our PC is down there. And it's going to apply my ACL in the inbound direction. So that is just how we can do NETCONF. So let me save that. And then we can run it. Ansible playbook. Again, I'm just doing an independent playbook here, netconf.yaml. And it is targeted to the switch group. But in this case, we can limit it further to just switch 1, because just switch 1 has the PC that we're interested in. So let's go to switch 1 real quick. All right, and before, let's see if I can catch it before. So this is what the access lists are by default. And it is failing because we do not have NC client. So one thing we need to do is install NC client. This is the Python package that allows our device to use NETCONF. So let's run the playbook again. I'm leaving some of these errors in just so you can see what to do. In the real life, you'll hit more errors than it'll work. So now it's failing with could not open socket. So I'm running it again. I did not make any changes. I think it just took a while for the switch to spin up the NETCONF process. I did not have to change anything. And it looks like it did make the change here. So it configured our ACL and then it applied it. If we go to our switch, show access list, there's the ACL, and then it should be applied on gig 101. There it is. So if we go to PC1, can we ping 8888? No. But can we ping 9999? We can still do that. Yeah, so that did work. I think it took a while for the switch to come up and synchronize and actually be ready. So if we were to run that again now, it should again be idempotent and it should not make changes. All right, so that looks good, and that was just a quick example on just showing the possibilities you have with NETCONF. You can also use RESTConf. You can use the CLI, but I think this wraps up this video and series, and just showing a quick example of how we can automate a network from the ground up, from turning it on all the way to interfaces and routing protocols, and then a quick NETCONF example. Thanks for sticking around.